Yeah, this is another one of those topics for people where experience teaches you bitter lessons, right? Until you actually get a hang of it. So what we're going to talk about is baked-in runtime failure identification or instrumentation, and that's basically the notion. If you have a big enough system, if you have moved from the pet stage to the livestock stage in your machines and your processes, where they can auto scale and can do other things, or they're automatically deployed. The question is, how do you know what's going on, and then what can you do about it? And this originally was a talk about health check endpoints, and it kind of morphed, and we'll see where we end up. And the root of any time we're doing runtime failure identification and remediation is instrumentation and metrics, right? Have you inserted probes into the system in places? Do you have instrumentation available? And do you have a dashboard? Do you have statistics available that tell you generally what's going on? And for everything we do, there's two sides of this. Once you have instrumentation and metrics, right? I said identification and remediation. And the identification side of this is triage, and the remediation side is remediation, actually causing it to be fixed, right? And we always want to stay on the right-hand side of this table. We always want to be automated as much as possible. There's going to be a certain class of problems that we can't be automated for identifying problems and having them fixed, but there's a whole class where we can actually, and then we don't have to go out and troubleshoot these. And sometimes remediation is fixing something, and sometimes it's just taking something out of service. Instance out of service that feels like it's unhealthy or got whacked or something, right? So we have manual triage. That's where you go and look at the instrumentation and you figure out kind of what's going on. And if you're doing manual triage, you almost always have manual remediation, although there are some systems that are semi-automated. You can say, oh, I know what this problem is. Let me hit this big red button that cycles this or redeploys or does something else, right? And then manual remediation is obviously the devil's tool, because manual remediation of a problem always involves these two hands and the brain, and hands and brain usually are not the right thing to do. You don't want to be doing manual remediation in your nuclear plant like some people have done before and caused major problems. Pretty much every nuclear plant outage has been manual remediation. So then we have automated triage, and that would be where the system identifies its own problems, and typically you might be super smart about that. You could still fail into manual remediation, but what you're hoping is for some subset of the problems that are identified with automated triage that you can actually do remediation. And what would that mean? That could be a redeploy. It could be a bouncing of a server. It could be waking something up. I don't know. We'd have to think about it. So drilling into system health, right? I just did this really stupid diagram with a bunch of lousy icons, and we basically have a person, and that person's using some web app, and there's some content services, and it's got some load balancer, balancing. I hope I did that right. Anyway, and then there's some compute, because there's some services, and then the gray things are all the kind of control plane part of this, right? In a way, the load balancers or data flows through them, but they're really part of the flow control mechanism, right? And then we have compute controllers. So if you were in Kubernetes or some kind of small auto-deployed service farm, any kind of PaaS service, assuming you weren't stupid enough to go back to your on-prem, right? Unless you're going to run your own Kubernetes. Anyway, or something simpler than Kubernetes. The idea here is that we have instrumentation plugged into the app services and the content services, and we may also have instrumentation in the control plane, and then we have second tier services, and the yellow thing there with the envelopes is a messaging, and what are we going to do with that? And then that's actually going to be out of scope for this one. And then we have the database tier, right? And there could be problems in the database tier. And so the question is, how do we know the health of this system when we're looking at it? What are we going to do? There's front components and back components, and if we need to know the health at the front, do we do and probe everything independently, or do we go through the top somewhere and do deep probing on that? So what's out of scope for this discussion is messaging health, any kind of message or event streams, functions, because they don't have endpoints, and this really started as an endpoint discussion. But we might be able to adapt this to functions, and basically any non-API functionality. I'm really just talking about API for this because I've only got 10 minutes and we're halfway in. So what are the different concerns? It depends on the tier you're in, right? The user only cares, does it work? The load balancer says, can I route, right? Can I get to the component I need? And if not, what am I going to do about it? The compute controller wants to know, is it healthy? Are the compute services, do they look like they're up, and that kind of thing? So in a Kubernetes or any kind of PaaS compute environment, app services, those kinds of things. Is it unhealthy? Are instances unhealthy? And the compute services are there any resource issues? Did we run out of memory? Does an individual compute instance, and there's really compute and data is what we're talking about here. There are more, of course, like directory services, those kind of thing, but we won't talk about that right now. Actually, they might be a dependency, right? Are the dependencies up? And those dependencies could actually be web services, database, message queues, could be anything, and that's where we would pull in some of the other components for testing this. And then the health check types that we can do against those resources are basically shallow and deep, and they both have their advantages, right? And so shallow ones are super incomplete. They basically tell you, hey, do I have network visibility to the endpoint? Can I connect to it? Is the port open? Do I have my configuration right? Do I have passwords, usernames, credentials, managed identities, those kind of things? Is there some test-specific endpoint I can ping that simulates business functionality so I don't cause any problems? Those would be shallow. What that means is that checking that you do doesn't go deeper than the first level service, and that's totally cool. A lot of very shallow testing, like for load balancers, a lot of times is just like, is the port open, right? But that doesn't tell you if it's actually working, and then you have to decide how deep you're going to go with a check. And, are you going to go and access configuration and secrets and actually try and make that work? I guess I put configuration in both of those. You got to decide, is the configuration there? Right? That would be a shallow check, and a deep check might actually be logging in to the backend service as part of your check. And that would assume that the backend needs to be up. And shallow services are great because they tell you certain things, whether an instance is up. A deep service might tell you, check will tell you whether the thing's actually working, but there are pros and cons to both of those. Are the dependencies reachable? That was the network visibility, right? So in shallow, it would be just like, can I reach this thing? A deeper one would be, like a mid-level would be, can I see the dependencies that I'm on? And then a deeper one of that would be, I would go to the health check of the dependencies and see if they're up, right? So we could have a cascaded dependency. That causes its own issues depending on the type of automation or remediation we want. But basically the idea is, do I check very basic things, or do I also check that I have connectivity and I can authenticate or whatever to all the services that I call, and then do I call them in some way to see if they're really up? And the risk here for this on the deep side is you can do dependencies of dependencies, right? So I'm dependent on 5 services in a database. They're dependent on 5 services in a database. They're dependent on 5 services in a database, and suddenly I've checked 100 things. That might be really cool, but that probably is lousy for auto remediation. The deeper you go, probably the better it is for manual triage and then manual remediation or manual problem detection. And then the recovery strategies we typically use depend on the tier of what you're working on. And so, like, a user's recovery strategy is, I'm just going to come back later, or I'm going to go to another site, whatever it is, right? That is a manual retry for that user. They might hit the reload button a couple times and then go away and come back later. And then a recovery strategy for a load balancer, right? You have a load balancer in front of a set of compute resources so that you can scale up, you can scale out, right? And then what happens at load balancer recovery, automated recovery strategy, right, might be to remove an unhealthy node. So I go and I've got 10 instances behind the load balancer. One of them isn't responding. It could either be responding at not at all or slow, and I might just take that out of the load balancer pool, right? And then a compute controller might have a bunch of compute services. So let's say Kubernetes, let's say a PaaS service with a bunch of compute nodes on it. Could be a fleet of functions depending on how they're working. A lot of times what we'll just do is restart. You know what? In the cloud, man, I got 40 instances running or 10 instances running, and one of those is down or not responding to a health check correctly. Just restart it, right? No big deal. I got other compute resources out there. I could do a redeploy. I've seen that too a couple places. We just assume after a certain period it's a bad deployment, we might redeploy, but that'd be a restart. And then in the compute services themselves, when they have what would be a recovery strategy, they could defer some action till later if a dependency is down, right? And they could queue it up in some retry mechanism, or they could actually implement some level of immediate retry or deferred retry. And then if the dependencies, what are their recovery strategies? You know what? That's someone else's problem, and I don't really care, and I'm assuming they're going to take care of that. So what are the remediations and risks that we can do? We can disable an instance. That's pretty common, right? You basically take it out of the load balancer, and then you suddenly find out that like 90%. I worked somewhere, and like we had a couple times where 80% of our resources dropped out of the load balancer, right? Because we had a great job of making sure the load balancer only went to live, but we didn't have any automation after that happened, and we had lousy notification. Another option is to do a redeploy of an instance. That might be in Kubernetes. That would be a pod restart, right? A redeploy. You can just do a remediation for certain kinds of problems. Might just be a general retry. You could retry a request, right? So I'm a service, and every so often I go out and see if the instance, my dependency's up, and if it comes back up, I do retries or whatever it is, right? Another one is you can fail over to another AZ, right? We have some kind of problem. More than N% of the nodes are down. We're just going to fail over to another availability zone or another region. I'm assuming you're in the cloud and not locked into your crappy data center where you don't have any failover capability. Or maybe you're a genius company and you do have it, right? And then notify the other possible actions to just start alerting. This is the worst of all possible things. Now, if you expect action, right? That implies people know what they're doing. They get on call. Now, part of the deal is when we recognize something, only a certain percentage of the problems can actually be remediated. And sometimes we're going to take a remediation approach, and that might work a good percentage of the time. And sometimes it just doesn't work. So like I restart those guys 4 times, it doesn't work. I fail over to the other AZ and we're down. Now all the AZs are down, right? Or the other regions are down. So the risks, right, for disabling, it's really hard to differentiate a transient outage from a hard outage. And by transient, I mean, a couple seconds or less, or a couple minutes or less, right? So if you see something's down and, is it really down or was it a transient error, right? And we could do a restart, right? So you'll see this with pods. We're actually going to restart instances. I've actually seen this where we did the wrong health check and we said if an instance is unhealthy, we're going to restart it. Super fast way to... That's reboot, right? Kind of like what the astronauts used to do on Apollo missions, right? They used to call cycle it. That was restart the spaceship, right? And so in this case, right, the problem with that is you can create a storm of restarts. Oh, we ended up restarting a bunch of things, and it's because the health check incorrectly determined that it was unhealthy. It was actually dependency that was unhealthy, or something where a redeploy didn't work because the environment it was in didn't work. Another one is you can create a activity storm or retries on the retry one, right? And you'll see that we'll just create 1 million retries, and then we'll put those on long retry queues, and suddenly we've created this huge list of retries, which actually may take down a partner team. And then we have failover. Transient recourse is not errors. Transient resources. I don't know what I was thinking there. You know what? I will fix that slide. And then, notifying people, that's the worst, right? And then the other problem you have is you got to recognize the difference between a system problem with a health check and just bad data, and do you have a way to move bad requests to the side or ignore them? That might actually be a code change or a dead letter queue of some type. So health check, depth by need, instrumentation, dashboards, what do they need? Are they going to be shallow or deep? UI checks, are they going to be shallow or deep? Load balancers in a lot of ways only care if an instance can take traffic. They don't really care if it's really down, right? And so you got to decide whether those load balancer checks are deep or shallow, because the partner team could go down, a load balancer will take everybody out of the rotation pool, and you're down because the load balancer got the wrong answer. So you got to make sure the checks are checking the right thing based on the need you have. And you could have instances that have internal errors or dependency errors. They weren't deployed correctly. You actually need to do a rebuild, or you're going to do other things. The point is you're going to do health checks against everything one way or the other. You're already doing this no matter what. And the depth you're going to do this is based on the need. So Spring probes. Spring, man, has some Java Spring has amazing instrumentation plan. I don't understand why other people don't do it. It's super cool. And that's it. Have a great day.